Welcome to my second video in the third chapter of our ActionRPG project. In this video, we're going to look at actually starting to set up the enemy's script, but focusing specifically on getting the enemy to take damage from the player's different attacks. So then in future videos, we're going to do movement and AI, but right now we want to make the enemy into a punching bag. So, continuing from where we left off last video, we created an enemy, we gave him some animation, and we didn't actually code anything. So what you'll notice if you playtest is you can push the enemy around. The enemy has no AI. The enemy doesn't take damage from anything, but it still obeys colliders. So like if I go push it against the wall, we can see that it gets stuck there. And so that's going to be some stuff that we'll eventually be playing with. It's still going to slide around when we bump it. Later, when we get to the enemy actually moving itself, we'll get it to not just get pushed around. All right, so with that, we're going to need to do a couple different things. And the first up is taking a look at making a physics material for the enemy. And that's so that it can have different bounciness when we start hitting it. So the idea is that maybe I want the slime to really bounce off things. Like if I slam it into a wall, it should bounce back a lot harder than a skeleton might. And so let's kind of set that up because we're going to use it as we begin to code this. So inside of the assets folder, right-click assets, and we want to create a new folder. And I'm just going to call this physics. And this is going to be where I put my physics materials. This is separate from the materials folder, which would actually have like skins and stuff, the mats. This is a physics material, so that's why I've made a separate folder for it. So right-click the physics folder, and we want to create physics material 2D. It's under the 2D folder. So we're going to choose that. And we're going to set up the behaviors. This is out of a scale of 0 to 1 in terms of what our settings are going to be. And like if we were to set friction to 1, that means it kind of stops. It's considered like a stopping object in terms of when the player brushes into it. But I think the player would still be able to push it. And a bounciness refers to how bouncy it is when it hits like a wall or something. So if it's a bounciness of 1, it's fully elastic, meaning it will bounce back with as much force as it hit. Bounciness of 0.5 means it loses 50% of the magnitude of its velocity when it hits a wall and bounces. So anyway, it called it new physics material. We could give it a name like, I want to call this bouncy, because this is going to be more of a bouncy material. When we have the orange blob prefab selected, you'll notice that there's a slot for material both in the collider and the rigid body. I don't remember which one overrides which. There we go. I think the collider overrides the rigid body. So you can define it in both places, and that's what I am going to do. It doesn't like multiply it. I think it checks the collider first, and then it checks the rigid body, and then it checks the default physics settings, which would be under project settings, physics 2D, and you can see that there is no default material. Anyway, so we gave it the bouncy. We really won't see this play out right away until we get to actually causing some physics impacts on it. As far as the friction, it's really hard to tell the friction, the effects of the friction, just because of the way that we're handling movement. So I would actually recommend dropping the friction to 0 and the bounciness to maybe 1 or 0.9. So it loses 10% of its velocity when it hits a wall. You can actually see that it makes the player kind of bouncy on it as well. So we might even want to consider making a new physics material called not bouncy for the player. And that one's going to have a friction of 0 and a bounciness of 0. So the player kind of slides off things like the walls and other things. So I'm going to assign this to my player prefab. Now there'll still be a little bit of bounciness when we do all this, because what's going to happen is the blob's going to bounce when I bump into it, and I don't as much. But I mean, you can always play with that if you don't really like that. But the main thing is so when we hit the blob, it bounces. Okay, so now that we've got the physics material set up, let's go and start creating a script for the enemy. So right-click your scripts folder and create a new folder called enemy. Inside of that folder, I'm going to create a C# script, and I'm going to call this enemy. Now, I'm actually going to set this up so that I can use inheritance. And the idea with that is if I code all of the main functionality inside of enemy, then my orange blob enemy can have a specific script, and let's make that right now. Let's make another script called orange blob. And this orange blob script is going to inherit the properties of enemy, and it could override or tweak them a little bit. So if I want it to only have a melee attack, then the orange blob script will only make use of the melee attack. But enemy will have the capacity for either. So by the time this is all done, you'll see why I have set it up that way. But it's going to allow us to add new enemies extremely easily, and then also tweak their behaviors. So let's open up enemy, and while we're at it, we'll open up blob as well. So inside of enemy, we've got to start actually setting up quite a laundry list of variables. So let's just start with some generic stuff. And that's going to be, let's go with a public string enemy name. This is going, in case we need to use a log or something, this would be the, basically the name of the enemy type. It's not like a unique identifier. It's just so that you can call this like blob or give it a name if we want to use it. And I think, well, we'll put our draw gizmos here. We'll do this with a serialized field just to make the difference. Now you'll see that I'm not using private. I'm actually using a variable type called protected. And a protected variable is going to be accessible in classes that inherit from this class. If this were a private variable, when I start doing orange blob, when it decides to start inheriting from enemy, it would not have access to seeing this variable. But I want the child script to be able to access this variable, so I choose protected. Public obviously would still be accessible by any sort of child object. This is the drawing offset, and we'll eventually set up some gizmos for this. So then we'll make our component collection that we need to be able to keep track of. And again, these need to be protected instead of private. Remember, if these are private, the orange blob class would not have access to them. But I want the child class to be able to see things like the sprite renderer variable. I think it's also called protected in Java. And then, so we've got sprite renderer, we need the rigid body. So what did I call that in the player? I think I called it lowercase a animator. Yeah. And then we need the, what else do we need? Oh wait, wow, I got that totally backwards. The rigid body will be called body, and then the animator will be called lowercase a animator. And then we could put some, well, we'll keep the components separate. Um, Next up, we will probably need some stuff for movement. We're going to go into movement in more depth later, but at least want to create some of the public variables here. Public float move speed. We'll set that to 10. And I don't know, that's probably under health and combat. So for health, we're going to need stuff like our max health. So health max. We'll just set that to an initial value of like 30. And obviously we'll change that inside the Unity editor. We're going to need a variable for and that's protected, so again the child class can still see it. It's a few things related to being stunned. We're going to create a Boolean called is stunned, and that'll be false initially. And I think that's probably all we really need for health. Oh no, we need some of the flashing things. So we have one called hit flash ticker, which is going to be the thing that is going to kind of track how long we are going to flash between being tinted red and being tinted the normal color. We got a hit flash duration, which is going to be the total time that this object will be flashing. And then we'll do a, we'll call it is stunned ticker, and that'll be how much time this object is stunned for. And so that kind of sets up most of those. We will eventually need some categories for like attacking, and we're going to need some categories for AI stuff, and we're going to eventually fill those out. But for now, this looks kind of looks good for what we're going to need. So let's start setting some of these things up inside of the start. So let's link our components. And let's go with body equals get components, rigid body 2D. Then sprites renderer, lowercase s sprite renderer, equals get components, sprite render, capital S sprite renderer. Man, I can't spell right now. And then we need to link the animator to get components, animator. The big three that we use a lot in 2D type games. Is stunned is going to be initialized to false. We can change our health current to health max. So we set up our health. And I think that's probably about all we really need here. I think under movement, I do want to add one more thing since I'm thinking about it. We'll add a protected vector 2 called home position. And we're going to just set that up to be where this thing spawned at. So we're going to say home position equals transform dot position. Because tracking where it started could be useful. All right, so that's going to set up our initial things. Now, something cool, in case you get sick of calling this health current, if you want to rename it, just remember if you right-click it and go to rename, what this will do is it'll let you rename a variable, and all copies of that variable rename with it as well. So that's actually probably the preferred way. Then you click apply, of renaming something, then like changing it everywhere inside the program. All right, so we've got that. Now we need to start, I guess, setting up the update method here. Now this update method is going to essentially be inherited by the blob. So we do have to use some more C# keywords. And if you're familiar with Java, it's actually a little bit, normally in Java you can override a method just by overriding it. But in C# you have to be more explicit about it. So I have to say public virtual void update. Virtual is a keyword that allows this to be overridden in a child class. So it's giving this method the permission to be overwritten by another one, but it's still accessible, and we'll see that in a second. So let's set up the sprite drawing order, and I think that's over here in player. This part, where we set up the bottom part of where we draw the stacking order. I'm just going to copy that out of player. Since I never remember all those numbers. The one thing I do want to do is I want to also add the offset Y to it, because some enemies you may want to appear higher, such as bats. Like the actual graphic might be bigger, but you want it to appear higher in terms of a stacking order. And so that's what we're going to have with that. So that's our update. Then we've got some things that we'll eventually add in here. And then I guess we need to actually start programming it to get hit. So let's move on to that. So let's start writing the method for this thing to receive damage. And so that's going to be called public, if I can type, public void hit. Not on controller hit. So hit's going to be a method we create, and we will have the first parameter will be the incoming damage, which is an integer, and then a vector2 for the force direction. So which way is this thing going to be pushed when it gets hit? So when something gets hit, this is where you could apply any sort of like armor to things if you really wanted to kind of add that type of system. But if the enemy gets hit, we're just going to take away some health. We're going to say health minus equals incoming damage. And we're going to check for death inside of update instead of here. And then we're going to apply the knockback force. Now keep in mind, force direction already has knockback multiplied into it. So we don't need to really do anything extra. So we'll say body.add force direction, comma, force mode 2D dot impulse. All right, so if we've been hit, now we want to make this thing stunned. So we're going to say is stunned is true. And then here's the thing, the is stunned ticker, how long do we want it to be stunned for? That's kind of relatively hard to say. You could try to make it based off of the knockback or make it based off the damage taken. I kind of want to base it a little bit off the knockback, so I might do something like, I don't know, we'll have to play with the math here. Force direction dot magnitude divided by 10. And maybe we'll print that out just to see how long that's going to be in seconds, and then we can play with it from there. Then we need to also set up the flashing. I'll just do that right here. We'll do hit flash duration equal to 3 seconds. and we'll tell it to play the hurt animation. So if animator is not equal to null, we will send the animator the command set boolean. We're going to set is hurt to true. Okay, so that should apply what we need. It's not going to start flashing us yet, but this thing should be able to get knocked around. So we could actually test that. We can save it right now. But right now, our player, the stuff isn't applying knockback or anything. So we need to jump over to the sword slash, and let's kind of code in the ability to hit something. So I'm inside of the player's sword slash. We're going to use a method called onTriggerEnter2D. I'm going to rename this from collision to other, so I think that makes more sense. It refers to the thing that you're hitting, the other thing. So if other dot, I think we can do compare tag. So if the tag of the other is an enemy, then we know that it is going to have this script. And then also, we started creating this array list of already hit things. So, and the enemy has not already been hit. That way we don't apply an infinite number of hits in the span of, like, as long as this animation exists. So if it is an enemy and it hasn't already been inside of my already hit list. So we will have to then, we already have access to the player because we assigned the player variable over when this thing gets spawned. So we need to figure out the source direction. And that is going to be the player dot transform dot position. And then let's do this. So basically, we're creating a vector, and so what's really happening behind the scenes here is if the player is here and our sword slash effect is right there, and let's say even though the enemy is right here, that's our blob. What we're actually calculating here, we're figuring out source direction, which is this position right there, and then sword direction is this position right here, and then we're going to calculate the vector going from here to here, so that when we hit the enemy, it applies that same vector to the enemy. So it goes like this. I actually calculate it like that because what I don't really want, and maybe you would want this, if we calculated it purely from the center of the enemy to the center of the slash, it would actually knock the enemy like that. And I don't know. So like if the enemy was like right here and you hit it, and now it's going to smack the enemy that way. And so it makes more sense to just kind of launch the enemy in the direction the player was attacking, then calculating the vector from the center of the sword to the enemy, because you, like, if the enemy was right here, it's going to smack it straight into you. So that's something to think about when we're calculating the knockback direction of things. I'm actually just calculating the vector from the player to the sword slash, to the center of the sword slash, and applying that same direction to the enemy's knockback. See, an MS Paint diagram is worth 1,000 words. Anyway, so we need to calculate that vector now. We'll call that hit force, and that's going to be, what is it? It's going to, I think, be, oh, my brain just stopped. Sword direction minus source direction. I guess we'll find out real quick if it doesn't work. Dot normalize. And that turns it into a unit vector so that the magnitude of this vector is always 1. Which is important because, like, if the sword, if like the magnitude of if the distance from here to here was like 1.6, it's going to kind of mess with our knockback. And so we want to turn it into the unit vector, and then we're going to multiply the knockback as a magnitude onto it. So that's why I got to pay attention in physics. And then I was using a scale factor of 10 for this stuff, so let's see how that plays out. Because I think that's what I was doing in the player fireball when we were setting up some of these effects. Anyway, so we've calculated our hit force. Again, we might need to play with that to see how we like that. And then let's access the enemy script. And so we can say other.getComponents enemy. And again, this is why we set it up with using inheritance. It doesn't matter what kind of enemy we hit, it's guaranteed to have this enemy script. So it could be a blob, it could be a skeleton, it can be a bat. If it's inheriting from enemy, all we've got to do is access the enemy script. So if you remember the polymorphism unit from CompSci, that is polymorphism in action. So we access the script, and we want to call script, not screen orientation, script.hit, passing in the damage first. So we're going to call it damage, comma, hit force. Then add it to the already hit list so that it doesn't consider it for being hit again. Because this, now to be fair, this only triggers for one frame. It only triggers the moment you enter into the sword slash. But I still need to do this because what happens if I hit it against a wall? My sword slash appears, the enemy bounces away, hits the wall, the sword slash is still in existence, and the bounce puts it back in the sword slash. It might register a double hit, and we don't want that. So by adding it to the already hit list, we can exclude it from being hit by this slash twice. And so that looks good. So we can hit save on this. And so now it will interact with an enemy. And to kind of make this a little bit more interesting, we'll just do source. Let's rename these. From source direction to source position. I think that actually honestly makes a little bit more sense. And then we'll rename this to sword position. And then if you wanted to play around with this, we'll add another one called enemy position, which would be the other dot transform dot position. And so you would be able to tweak this. If you wanted to see how this could also work, you could do enemy position minus sword position. That would do that kind of pinballing knockback that or the bowling knockback that I had showed. So you could consider trying that for your vector calculation, and that's an interesting one. Anyway, so let's hit save on this, and let's see if we can smack the enemy. Jumping back into here. We hit play. And we swing, and we miss. Swing and a miss. I think I know why. Is our blob tagged as an enemy? And it is not. So let's go switch the prefabs tag to enemy that we conveniently made 15 videos back. And so it's now can be enemy there. If you haven't made the enemy tag, just go to add tag and add capital E enemy. All right, so we've got an issue here. Object reference not set to a reference of an object. Ooh. Oh, okay, that makes sense. We have not actually attached the script to the enemy yet. And so let's go do that. Because it's trying to get a script that doesn't exist and try to send it to a command that doesn't exist. So let's actually set up the inheritance real quick. So jumping over to orange blob, instead of inheriting from mono behavior, we want to inherit from enemy. So replace that with enemy. And it's fine if this is blank right now. We'll eventually add some stuff to it. But let's hit save. Update's kind of mad, but it should still compile. So just call it public override void, and I'll be happy. And so let's just attach onto the orange blob. I'm going to attach the orange blob script. And you can see that it now has shown up here. I can give it an enemy name. I'll just call it orange blob. It has 30 hit points and all these other things. So we can go back and hit play. Now it has the orange blob script, but the orange blob script is inheriting from enemies, so it'll count as an enemy script now. Oh, still mad. Oh, I know why. That is the weirdest reason that that's happening. And it's because I have a start method here that's actually replacing the start method in the parent function. So we got to take out that start inside of orange blob because it was blocking the run of this, meaning body never got populated with that value. So when it was trying to do body.add force, there was nothing there to do. So there we go. It looks like I'm not calculating this vector correctly though, because as you can see, it's just kind of bumping to the sides. So let's see what we can do about that. And it would have been stunned for about 5 seconds, which makes sense because I was dividing that by that. So let's go with dividing it by 20. That should make a good stunned time. So let's switch it off of using the sword's position to using the player's position. And we'll do the... because the sword's position is actually not the center of the sword. We'll do that. So now it's knocking in the correct direction here. And it is hitting every time. Now, you can kind of see a little bit of odd behavior because I'm able to move before the hitbox completely disappears. I can kind of run the hitbox into the enemy. So something to consider might be some kind of deactivating the hitbox after that first frame of the sword slash. Because otherwise, you know, the remaining parts of that still can kind of count as a hit. And that's not very... good, I would say. So, alright, I'm going to take out this log command here inside of enemy hit. So I'm going to take and delete the different debug commands real quick. And I do want to actually kind of deactivate the collider in the sword slash because that was getting kind of silly for it to hit it. So we're going to make a method here called public void disable collider. And what we're going to do is, I don't know if, are we accessing the collider? No, we can just access it directly. We can do get components collider 2D. So it doesn't matter what collider you're using. Dot enabled equals false. So we can, inside of the animation, turn off that collider so that the sword only hits during that first frame. So we'll go back to here, switch over to our sword prefab of all things, go to its animation, and I want to turn off its hitbox basically when this new frame appears. So I'm going to put an animation event, and I'm going to tell it to disable trigger, disable collider, so that it can no longer register a hit once it switches frames, so that it will feel a little bit more natural. In like the entire animation's existence doesn't count as a hitbox, just that first. So like you can see how I moved it over the enemy that time, but it didn't register as a hit. It only registers on that first part of the hit animation. All right, so we've got an enemy moving around, but this video is already kind of getting to the long part. So if you want to play around with the physics, I would recommend adjusting the bounciness to something that you think makes sense, or maybe disabling a lot of the bounciness. That's up to you. But in the next video, we'll do some, get the hit flash working, and we'll probably do this, set it up on the player as well. So we'll work on creating the player's hit method and the hit flash effects. So thank you for watching.